Our Earth is covered in water, but fresh water makes up a very small fraction of all water on the planet. About 70% of the Earth is covered in water, but only 2.5% of that water is fresh. The rest is seawater and saline-based. Even more than that, just 1% of our fresh water is easily accessible, which a lot of it is trapped in glaciers and snowfields. So we should use desalination. Well, first, what is desalination? Desalination is a process that extracts minerals from salty or dirty water. Desalination refers to the removal of salts and minerals from a target substance, as in soil desalination, which is an issue for agricultural salt water, is desalinated to produce water suitable for us to drink and irrigate. Well, how does a desalination plant work? Well, seawater is pumped in 3 times slower than fish swim, so not as many fish get caught up and plug everything up. It is then filtered to get rid of particles such as colloids and algae. After this, only molecules of water and salt remain. It is then sent to a very high pressure through an extremely fine membrane. The pressure on the water is equivalent to about 100 elephants on a manhole. This process is called reverse osmosis. For every 2 liters of salt water pumped into the desalination plant, you obtain 1 liter of pure water and 1 liter of brine, which is about twice as salty and diluted as the salt water. There are many different types of desalination. There are plants, there are portable desalinators, and there's filtration, evaporation, reverse osmosis. So there are many different ways, but in some there are intake screens where the seawater flows into the plant through the open seawater intake structure with mechanical rate core screens, and then it goes into the flotation unit where chemicals are added. So it takes care of those bigger particles, and air is pumped in to make lighter particles float to the surface, so you can remove those particles a lot easier. Then you go into the gravity sand unit. The water is filtered through the sand and remove heavier particles. And then you go into the reverse osmosis unit. The pre-treated seawater is pumped at a high pressure through the semi-permeable membranes to separate dissolved solids. And then once the water goes through that, it goes to post-treatment. The water is demineralized. Lime is added to adjust the pH level and improve the taste. Chlorine is added to disinfect the water, and fluoride is added for dental wellness. And then you get into the final stage, the storage. The treated water is pumped to service reservoirs and distributed to homes. And that is it.
One good thing about desalinating water is that you can take an unlimited amount of water without messing with the freshwater ecosystem, like we do when we take water from the ground, rivers, and lakes. It converts salty water into drinkable water. Around 1,250 desalination plants in 150 countries provide around 140 million cubic meters a day of fresh drinkable water. The water quality is usually safe. The method is proven to be effective. It preserves our freshwater supply. There is massive amounts of fresh water, so as long as there is desalination plants, there is fresh water to be provided.
One downside of desalination is that it isn't very energy efficient. One of the side products of desalination is brine. This is a supersaturated water that must be disposed of. Most plants pump their brine back into the ocean, which can have bad interactions with the environment. The emissions created by desalination plants cause climate change, a leading factor of droughts and water shortages. Desalination isn't yet perfective. As of that, the water can be harmful to human health. Byproducts of the chemical use in desalination can get through to our pure drinking water. There are many other water treatment technologies that are more efficient. than desalination. The brine also lowers the amount of oxygen in the water at the disposal site, stressing or killing animals that are not used to the high amount of salt. It is also very costly to build and use desalination plants. It can cost from $300 million to $2.9 billion as of 2008 to make a plant. Once you can use these plants, they require huge amounts of energy. The energy costs about one half to one third of the costs for desalination plants. Our methods require about 14 kilowatt hours of energy to produce 1,000 gallons of desalinated water. So the price of desalination is high because of the electricity we use to desalinate seawater. Around 1,250 desalination plants in 120 countries provide 14 million cubic meters of drinking water. The top 3 desalination countries are Saudi Arabia, with 17% of the global desalination, United Arab Emirates, with 13.4%, and United States, with around 13%. One of the main types of desalination is called reverse osmosis. This was invented in California in the 1950s. It takes about 2 gallons of seawater to make 1 gallon of fresh water. Those are some interesting facts about desalination.